All right, this is 2B from page 437, the chapter review. It says, solve by setting it equal to 0 and factoring. To solve any quadratic or higher degree function, you always want to get it equal to 0, and then attempt to use something called the zero product property. That's a property that's been at play all chapter. Haven't really formalized it and mentioned it, but I think we've talked about it before. You want to get these equations equal to 0, so you're going to bring 15x squared over to the left. The reason that you want to get them equal to 0 is the zero product property says if anything times anything else equals 0, what's true about A and B? One of them has to be what? 0. Well, that'd be true if there was a C there as well, or a D. So instead of quadratics would just be A times B, all right? But if it's polynomial, you could factor it into many different pieces. And if it is, it's possible that A equals 0, or B equals 0, or C equals 0, or D. Polynomials are going to have many factors. So here's what we do. Now that we have this problem set equal to 0, let's tack on the little squared that I forgot. All right, so now it's equal to 0 and factor. What do these all have in them? They actually have an x squared in them. Is x to the fourth at least x squared? Yeah. Is that exponent at least is 2 or higher? Yes. Then there's an x squared in there. So we're going to factor out that x squared first. Anytime you can do this, do this. If these all had a 2 in front of them, factor out a 2. If it was 3x to the fourth plus 6x cubed plus 9x squared, you'd pull out a 3 because they would all be multiples of 3. You're pulling out the common factor. Well, once you take an x squared away from x to the fourth, what does it become? And what does the 2x cubed become? And what does the 15x squared become? Just 15. So now you take a look at the quadratic that's there, and if you're not good at factoring yet, you need to get there. All right, you need to look at this quadratic and say, oh, I can factor that to x times x. Factors of 15 that differ by 2. 3 and 5. Who gets the plus? The 5. So now we have a quadratic. Not a quadratic, it's a polynomial in factored form. And we actually have it in DABC form. It's almost like x times x plus 5 times x minus 3. So we have the 4 factors of this. Well, for this to equal 0, what are the potential solutions for x? What would you plug in here to make 0? 0. What would you plug in here? -5. In here? 3. Those are the solutions to this problem.